Welcome to the Algebra 1 Structure and Method textbook series. This lesson is on Chapter 11, Section 6, the Pythagorean Theorem. In today's lesson, we're going to learn how to use the Pythagorean Theorem and its converse to solve geometric problems. Before we start, you should know how to simplify radical expressions, and you're also going to learn a few new words. Let's get started. Let's start by warming up with some radical expressions and substitution. Evaluate each expression for the given values. Round your answers to the nearest hundredth. So restart the video when you're ready to check your answers. I'll count it down in 3, 2, 1. How did you do? Hopefully this felt pretty good. You're going to be doing a lot of this kind of substitution in the lesson today. You might remember this from primary school, but let's review the parts of a right triangle. A right triangle has one 90-degree angle, and the side across from the 90-degree angle is called the hypotenuse, commonly denoted as C. The other two sides of the triangle are called legs, and we use A and B interchangeably as their names. Well, we use the Pythagorean theorem to find the lengths of the sides of a right triangle. The theorem states that the sum of the squares of the legs is equal to the square of the hypotenuse. This is commonly known as a squared plus b squared equals c squared. You will remember that probably forever. Again, that's the sum of the squares of the legs. That equals the hypotenuse squared. Let's begin with an example. The length of one side of a triangle is, a right triangle, is 28 centimeters. The length of the hypotenuse is 53 centimeters. Write and solve an equation for the length of the unknown side. Well, let's begin by drawing our triangle and adding in our side lengths. We leave one variable as our unknown, and as you can see, it's one of the legs. So I'm going to set up my equation for the Pythagorean theorem. A squared plus 28 squared equals 53 squared. Now I'll simplify my squares. These numbers get a little bit big, so feel free to use a calculator if your teacher allows you to do so. I'm going to subtract 784 from both sides, and I get that a squared is equal to 2025, and the square root of 2025 is 45. Now, we have the converse of the Pythagorean theorem, and this basically states that if a squared plus b squared equals c squared, and c is your hypotenuse, then the triangle has to be a right triangle. And we can use this to determine if the side lengths of a triangle make it a right triangle. Let's put our knowledge of the converse theorem to work. State whether the three given numbers could represent the lengths of the sides of a right triangle. Go ahead and give this a try. Pause the video and restart when you're ready to check alongside of me. I will start in 3, 2, 1. All right, I'm going to start with my Pythagorean theorem, a squared plus b squared equals c squared. I'll plug in my values of a, b, and c, and I've got a little question mark over my equal sign because I don't know if this equality is true or not. Now keep in mind your hypotenuse should always be your longest side. So I'm going to simplify each side and check to see if it's true. In this case it is. So part A, we have a right triangle. Why don't you try part B if you didn't try part A on your own? And I'll get started now. Again, my Pythagorean theorem. I substitute values of A, B, and C. I simplify both sides and I get, 835, which does not equal 900. Example 2b is not a right triangle. Let's end with a word problem. To the nearest hundredth, what is the length of a diagonal of a rectangle whose width is 18 centimeters and whose length is 30 centimeters? I'll draw my rectangle and add my lengths. Then I'm going to draw my diagonal, which connects my two opposite corners. Now this is the hypotenuse of a right triangle, so let's name it C. Now, can you see your right triangle? If so, let's go ahead and set up our Pythagorean theorem. Plug in our sides. Now keep in mind our hypotenuse is C, so that's our unknown in this case. I'll plug in 18 and 30, simplify, and my answer is 6 square root 34. You may also have a decimal answer depending on whether or not your teacher allows you to use calculators. Well, it's time to wrap this up and show what you know. Turn to your classmate and answer the question, how do you think the Pythagorean theorem can be used in real life? You did a great job today, and I'll see you in the next lesson.